السلام عليكم ورحمة الله وبركاته. حد معايا؟
وعليكم السلام سير.
يا هلا، أهلا وسهلا. هعمل شير، حاضر هعمل شير ثواني. بدور بس على السلايدز. وإحنا فين؟ إحنا في Portability and Interoperability. Can you see the slides? Can you see slides now?
Yes.
Okay, thank you. Okay, so today we will cover the portability and interoperability of cloud computing. So we have passed long time of the course. We covered huge amount of resources in the course. Now we are in CLO for portability and interoperability. We still have next week we'll cover cloud management, and next week will be the last lecture. I think it's gonna be the last lectures because week 14, and then you will concentrate more in the project. We will talk about the project and help you to finish the project. So about the project, I wish you started right now to see the project and try to make some research about the different types of cloud computing platforms. And some of you sent me an email. They asked me to make or to make a project for AWS, Azure, and Google Cloud. I refused because nobody can do that because they are all similar. They are too similar. And I want you to understand main other concepts behind cloud computing, such as the cloud computing provided by IBM and the cloud computing provided by Oracle and SAP and other different services there. So it's acceptable to make research among two of these three, for example, Azure and AWS, and one of the other, none, you can say not public or not famous cloud computing platforms like SAP and Azure. Sorry, like SAP and Oracle and IBM and Salesforce and other. There are hundreds of services out there. So if you want to change the project topic, you cannot change it to work with AWS, Azure Cloud Computing, and Google. No, you're just like saying Amazon, Microsoft, Google. No, you have to change. You have to take two of them and one extra from other related cloud computing platforms. I wish you started the project, started to make some research, even if you start to make meeting between you, the different members of the same group, and assign a leader for the group and have a regular meeting at least once a week. Start this week. I think because you don't have too much time, the next week will be the last week for you to deliver the report. And after the Eid, inshallah, you should make your oral defense. Okay, today we are going to talk about two important concepts. Actually, they are not they are not sorry, they are not technology. Actually, they are not technology. They are just concepts, and these concepts need some technology to come true, to make them come true. For example, we have the portability and the interoperability. Portability means what? Portability means the program can be moved from one cloud service to the other and works smoothly without any change. Again, portability means to move the program or a service from one cloud service to the other without and still working, you can say, still working, jumping from one cloud service to the other and still working. No configuration needed to make it work. This is portability. Interoperability means interoperability means two different cloud computing services working together. This is interoperability. How much two different cloud services work together or can interchange services. So now we understand the portability and interoperability. We have what we call vendor lock-in. What is vendor lock-in? Each vendor or cloud provider make their own programs and their own services, and all these services cannot be moved to other provider because they make it assigned to their own hardware. They make it assigned to their own software. That's why it is very hard to move it from one place to another. Okay, so these are the two concepts of cloud computing, very important: portability and interoperability. And the portability means the software can be moved from one or move one component from one uh, architecture to another platform architecture, and they still remain operational at its full ability. يعني it's working at its full ability. Okay, so this is the most important thing, is that we move without any configuration. We move and it's still working. So in cloud computing, portability is the ability to move some computing constituent like virtual machine, development environment, or application from one environment to another. This is portability. It also means the ability to run components or systems developed for one cloud provider's environment on some other cloud provider's environment. So it's like, okay, have uh, for example, my calendar. For example, I have calendar on my PC. I can run this calendar on Mac device and also in Linux device. This is portability. If I can run the same program on different platforms, this is this means the program has the portability properly. So we need this. Actually, we need this in cloud computing. Interoperability is the ability of two or more systems or applications to communicate by exchanging information and deliver expected outcomes by processing those exchanged information. So interoperability means two different entities working together in a harmony. For example, you as a group in the project, if you don't have interoperability, you will not be able to work together, because interoperability means you can exchange information between each other, and uh, you have an outcome due to this exchange. Actually, interoperability has different levels. It has on public level, on private level, on a hybrid level. So they are they are different from one cloud service to another. And there is a relationship between interoperability and portability. Interoperability is an enabler for portability. If you have interoperability, means you can have portability. It's like the entity for portability, the entity is moving inside the system freely, but interoperability means it jumping from one place to another. So if it can jump from one place to another, so it will be able to be portable. So it's like ignition. Is the interoperability is the ignition of portability. What about the data? What about the data? Data is like if we talk about public service providers like Dropbox and OneDrive, you can say if we move uh, to the higher levels of services in the cloud, so we can say in application level. In the application level, like one cloud, and they are providing Microsoft Office bundle on the cloud, so you can save files, and then these files, if you can go to Google Cloud and open the same files using Google Cloud, this means they are portable. Again, you know that we used the Office on the cloud using Microsoft uses the public cloud for Office, so you can open Office documents online, no problem. But if it is portable, this means if you open Google Sheet, if you know about Google Sheets like Excel sheet, and Google Documents, and the other Google presentations, they are similar to Microsoft Office. So if you can open the same file which you created using Microsoft Office, you can open it with the Google Docs. So this is portability. This is portability. Okay, and portability also has different levels, starting from SaaS, PaaS, and IaaS. They have different translations. For example, if we talk about data at the SaaS level, this means the portability of data should accept should different types of cloud should accept different format, different extent, and different semantic. Format, extent, and semantic, they are too similar to each other. It means they have a specific format. So you different cloud computing services should be able to change these types of format or these formats. For the platform, a platform is talking about the operating system and the application development environment. It's talking about the operating system and application development environment. If you want to change or to move one application from one place to another, you can use it. APIs. The best way is to use APIs. And the APIs nowadays, they are the most important aspect of any software. If you cannot provide good API, nobody can deal with your software. It's like new concept of dealing with software. You don't have to go and buy the software. You can take the API and then contact to that software, and they get the result you want. So the best way for the platform as a service is to use APIs. And for the ES, which is the hardware level, you can use for specific format for machine images. For example, the virtual format, the open virtual format, or OVF. This is one of the most famous formats used by different types of different cloud providers. For example, OVF can be used by Google Cloud. OVF can used by Azure. OVF can used by AWS, of course. So we have seen the data has different translation, you can say interpretation. Portability has different interpretation in each one of them. Here we talk about the format. Here we talk about the APIs. Here we talk about a different specific format for the image or the machine image. To resolve the portability, you have to get to standardized data formats. This is the best way. For example, you know about MPG and MPEG for images, PNG. Every cloud should be able to handle such kind of formats and make different, or you can say make standards. So all of the cloud computing services go with these standards. For the application, as I told you, if you want to have an application interoperability or portability, you should use the APIs. If you use API, this means the application itself can be portable, because you don't have to, you should only use the API to run the application program interface, because this interface is designed to be independent of the operating system or independent of the application. So you make your API, and then you can migrate this API from one system to another. For the platform, the portability for the platform, we have two different options here for the portability. We have porting platform environment and the porting machine image. The platform environment means reusing platform components over the ES facilities for different vendors. So this is like related to the hardware and the ES level. Porting platform environment. And the other one is porting machine image. And in this case, we have a bundle of machine images, known as machine images. They are the seeds for virtual machines. And this is porting machine images. This is the scheme used in AWS. We have a collection of machine images, and then you can create, or you can instantiate instances from these machine images. Of course, you have to find a standard format so these machine images can be traveled from one vendor to another. And we said about, or we talked about the open virtualization format, which is OVF, and we are going to talk about this OVF in the last a few slides. For the application, for the interoperability, we have application. Yeah, the interoperability like two different uh, two different cloud service providers want to communicate to each other or to collaborate, you can say. So we have two different concerns here for interoperability, the application interoperability and the platform interoperability. And the solution for all of these interoperabilities is the standardizing APIs and standardizing data format. And also the last one is standardizing the protocols for service discovery. So it's the solution for application and platform interoperability is to standardize APIs and standardize format and protocol. It's like making a standard for everything. You can make it general. You can make this solution general. You can say standardize everything. If you standardize everything, there's gonna be interoperability between different vendors without any problem. But without a standardization, everyone will use his own scheme, his own format, his own APIs. Without standardization, nobody can deal with nobody. Mm. Okay, okay. Uh, there are two types of machine for instances and machine images. We have the machine image and machine instance. The machine image is like uh, an inactive entity holding a template. Machine image is like file, and this file is not active. It's like saving one file, like the ISO file. If you downloaded the ISO file of operating system, this is machine image. It contains all of the configuration, or contains the operating system and the installed applications together with their own configurations, together collected on one file. This file is called machine image. A number of machine instances, this is very important. A number of machine instances can be launched from one machine image. So the relationship here is one to many. So one machine image can have many machine instances. Of course, we can have a pre-configured set of machine images. One machine image is for security, one machine image is for database, and one machine image for network, and so forth. We can have different configuration for each machine image, actually. And this is the power of machine images, actually. And the machine images are effective in disaster recovery because if one image is destroyed, you can have, if one instance is destroyed, you can have again retrieve the data from the original machine image. There are machine images and machine instances in Amazon. The machine images, we call it a Amazon machine image or AMI. I call it AMI or AMI. AMI. I don't know how to they pronounce it in America. They pronounce it differently, but I call it AMI for because we are in Arab world, so I used to call it AMI. So Amazon machine image is the machine image. As I told you, this is a machine image, so it contains an operating system together with a collection of applications and specific configuration. We have we can make instances of these images using the EC2, the Amazon Elastic Compute Cloud. So you go there in EC2 service, and then create from the available images. You create the instance that you want. For example, you can create an instance for Linux operating system. You can create an instance for Windows operating system, and so forth. So you have to see all the available list of images, and then you choose which one is suitable for you, and then make it available using the EC2 service. The most important information here regarding the machine images, it is encrypted and stored in the Amazon S3 storage. For Azure, we have also for Microsoft, they have Azure Virtual Machine Image, and they call it VM image actually. And the VM image contains an image for the operating system as well as the images of all the disks attached to a virtual machine while creating the image. So also Azure offers a gallery of images, contains many images. You can instantiate any new virtual machine from them. Also, it allows the capture, which is creating new image from already existing image. For example, you can launch this VM image and then try to change the operating system or try to change some of the applications and then create a new virtual machine image. This capability they call it captured there in Microsoft Azure. The image file not stored in S3 as AWS, but it is stored in VHD, virtual hard disk, and this is the user's default storage location. Virtual appliance. Virtual appliance is a pre-integrated self-contained system consisting of pre-configured just enough operating system. Okay, just enough operating system, call it JOS, JOS or JOS. And one of the students one day told me, said it or pronounce it like Jesus. So it is JOS, not Jesus. Okay, just enough operating system. Just enough operating system is very tiny, small operating system with single application and single config, just a small set of configurations. This is JOS. Okay, JOS is just enough operating system and small operating system with a small functionality and small application. One application only. So it is designed for that application. Wait a moment. Okay. For the virtual appliance, we have uh, closed virtual appliance and open virtual appliance. The closed, you cannot update the internal structure of the appliance, and the open, you can actually you can update the virtual appliance and add your own application, remove the already existing application, and change the configuration, and then make a new virtual machine image. The benefits of using virtual appliance. We have some benefits of using virtual appliance: simplified deployment, because the virtual appliance is just a self-contained unit, pre-integrated and self-contained unit, just a small. It's like I'm directed to specific deployment or is directed to specific application. This is the appliance. For also the size, it has less volume, and also it is more secure because you know we have only one single application, so the security is very high compared to the system with multiple application, because one of these multiple application can be malicious software. That's why. So one application has higher security compared to the multiple application platform. because there were no any other application running may disturb the other applications running at the same place or the same system. And here is a comparison between virtual machine image and virtual appliance. The virtual machine image contains full image operating system. The appliance it contains minimal required part of the operating system. This may or may not contain any application. This contains an application, and this may contain more than one application installed. Here, it generally contains only one application. The primary objective is to launch machine instances. Here, the primary objective is to launch application. In this image, other software application can be installed over machine instances. In this image, nothing can be installed over deployed virtual appliance. It is here in the virtual machine image. It is the image of virtual machine stored in a archival format as captured at some instance. Here, it is a type of virtual machine image in customized and reduced form. So we have totally different schemes here. The virtual machine image is a full machine image with full power, and here the other one is virtual appliance. The virtual appliance is small. Just to give me a second. Okay. uh, and for the cross-platform compatibility, if we have a virtual appliance, this is very nice idea to have minimal set of operating system and then one application running. But the problem is the format. So we said, okay, we can agree on one format. And this format that agreed upon is Open Virtualization Format, or OVF. OVF promotes virtual appliance portability. This is the main objective of OVF. So this is the OVF. This is the OVF, Open Virtualization Format. It's a standard which provides a standard packaging format for software solutions based on virtual systems. It's designed to resolve the portability issue of packaged virtual systems like virtual machine images or virtual appliances. So the main objective of this OVF is to solve the problem of portability between different cloud platforms. So we can say cross-platform. Cross-platform means it portability is cross-platform, means it can jump from one cloud provider to the other. It can be deployed easily and also can be configured and customized during installation, because it is not locked with only one application. Actually, it is not like that. It is pre-configured with small set of operating system features, and then a single application, but you can add another application. You can even remove the already existing application and add another, and so forth. Okay, so this is the open virtualization format, and we get to the end of the lecture. If you have any questions. So mainly portability and interoperability. Portability means the software or the service or the module can jump from one cloud provider to another and with full functionality. And interoperability means different cloud platforms can deal with each other. Okay. have any questions? Are you there? Anybody there?
بس
انتوا
دكتور
معايا
ما
ولا لا؟ اوكي. اسف انا يعني هو المفروض ان انا اقعد اسالكم كل شويه عشان كده بس يعني الواحد خلاص يعني كل سنه وانتم طيبين كده بعد العيد بقى يا خلاص يبقى الواحد هيفوق شويه. آه، مع ان المفروض الصيام يجمد الواحد مش يضعفه يعني. آه، هنادي الحضور. بس هو مش المشكله مش في الصيام عندي، المشكله في النوم. يعني احنا قلت لكم ان انا كنت في السعوديه والواحد متعود على جو السعوديه. رمضان الدنيا بتقفل والواحد بيبقى متفرغ للعباده والصلاه وقراءه القران وبس، مفيش حاجه تانية. طيب هشوف كده الحضور. 41 كلاود كومبيوتنج، اوكي. 17. عبد الله فيصل. عبد الله فيصل 41. ايه مالك؟ عبد الله عمر. عبد الله عمر. انا بنادي غلط ولا ايه؟ عبد الله فيصل، عبد الله عمر. عبد العزيز سعود.
نعم
موجود.
دكتور.
تمام ماشي يا عبد العزيز. عبد الرحمن. عبد الرحمن فينك عبد الرحمن؟ عبد الرحمن شكله مش موجود، مش موجود. استنوا بقى عشان ايه ما تغلبونيش. اللي يكتب رسالة واللي كده خلينا كده. ثواني بستخدم الشاشة على مرتين على جزئين. طيب عبد الرحمن خلاص مش موجود. عبد الله عبد الكريم. ها عبد الله عبد الكريم برضه مش موجود. احمد توفيق.
موجود.
تمام. تمام موجود. احمد اسماعيل.
نعم دكتور.
تمام موجود. احمد محمد. تمام موجود. فهد فيصل. فهد فيصل. ايه الشعبة اللي كلها السعودية دي؟ فهد فيصل وعبد العزيز سعود. غاية. غاية.
موجودة أستاذ.
تمام. حسن محمد. حسن محمد. خليفة جمال. خليفة جمال مش موجود. ميسة ناصر مش موجودة. ميرا. ميرا موجود. ميسة سليمان موجودة. ماشي يا ميرا. ميسة سليمان موجودة. عبيد راشد
نعم دكتور.
موجود. تمام يا عبيد. راشد عبد الحميد. راشد عبد الحميد.
نعم دكتور.
تمام. راشد عبد الحميد تمام. شيخة
نعم.
موجودة. شوق. شوق موجودة برضه. تمام ماشي يا شوق. خلاص تمام. خلاص كده يلا اشوفكم ان شاء الله يوم الاربعاء على خير ان شاء الله. طبعا احنا عندنا امتحان صح؟ عندنا امتحان الاربعاء ان شاء الله. يلا اشوفكم على خير ان شاء الله. مع السلامة.
مع السلامة دكتور.
الله يسلمك. مع السلامة يا عبد العزيز. ألف سلامة.